In this video, we are going to look at how to find the molecular formula from the empirical formula. We can find the molecular formula of a substance if we are given its empirical formula and its relative formula mass. So let us look at an example for this. Determine the molecular formula of the sugar glucose. It has an empirical formula CH2O and a relative formula mass Mr of 180. To solve this question, there are two steps that we need to follow. Step 1 is calculate the empirical formula mass. We are given the empirical formula as CH2O. To calculate the empirical formula mass, we have to add together the relative atomic masses of all the atoms involved in the empirical formula. To find the relative atomic mass, we have to look on the periodic table. The relative atomic mass, AR, for carbon is 12, for hydrogen it's 1, and for oxygen it's 16. Now we have to add all of these together. So empirical formula mass equals 12 for the carbon atom plus 2 times 1 in brackets because we have 2 hydrogen atoms plus 16 for the oxygen atom, and this equals 30. So the empirical formula mass is 30. Step 2 is divide Mr, the relative formula mass, by the empirical formula mass. The relative formula mass is 180, so Mr divided by empirical formula mass is 180 divided by 30, which is 6. And this means that the molecular formula is 6 times the empirical formula. So the empirical formula is CH2O, but we need to remember that if we don't write a number, it's normally 1 that we have there. So we have to times all the numbers in the empirical formula by 6. And this means that the molecular formula is C6H12O6 for glucose. Let us look at a second example. Determine the molecular formula of hydrogen peroxide with an empirical formula HO and a relative formula mass Mr of 35. You can now grab a piece of paper, pause the video, and have a go at determining the molecular formula for hydrogen peroxide yourself. Step 1 was to calculate the empirical formula mass. The empirical formula is HO, and we have to look on the periodic table to find the relative atomic masses so we can add them together to get the empirical formula mass. The relative atomic mass for hydrogen is 1, and the relative atomic mass for oxygen is 16. So empirical formula mass equals 1 plus 16, which gives us 17. Now step 2 was divide Mr, the relative formula mass, by the empirical formula mass. The relative formula mass Mr is 34, so Mr divided by empirical formula mass is 34 divided by 17, which gives us 2. So the ratio of these two is 2, and this means that the molecular formula is 2 times the empirical formula. So again, the empirical formula is HO, but we have to remember that if we don't write a number, it's actually a 1, and we now have to times the numbers in this empirical formula by 2 to get the molecular formula, and the molecular formula is H2O2.